A deadly cosmic death ray threatens all life on Earth, and it can hit at any moment. Enormous bursts of energy zap from the farthest corners of the universe, obliterating everything in their path. Now, I know what you're thinking. Cosmic death ray sounds like something straight out of a science fiction novel. But what if I told you that there is evidence of a gamma ray burst hitting Earth in the past and being responsible for one of the biggest extinction events 450 million years ago? Let me assure you, these gamma ray bursts are as real as they are terrifying. And they are not just any ordinary cosmic events. They are the most powerful, energetic, and luminous explosions in the known universe since the Big Bang, outshining entire galaxies. Astronomers have observed all the nearby gamma-ray burst candidates and found that most of them don't seem to be close enough or oriented to point their death beams at our planet. However, some extinct species might disagree based on the outcome. What would happen if we were to discover one of those beams aiming directly toward us today? What are the odds that a death ray is at this very moment threatening our existence by hitting Earth? In the 1960s, the Vela satellite launch was a pioneering mission designed to detect nuclear tests in space during the Cold War. The satellites were equipped with X-ray, neutron, and gamma-ray detectors, along with advanced data transmission equipment to relay crucial information back to Earth. However, the mission took a chilling turn when the team stumbled upon a discovery more terrifying and deadly than any nuclear blast on Earth. This program became famous for uncovering evidence of extragalactic gamma-ray bursts. To give you a sense of their power, consider this. A single gamma-ray burst can release more energy in 10 seconds than the Sun will in its entire 10 billion-year lifetime. Let that sink in. 10 seconds. More energy than our Sun will ever produce. Immediately after its launch, it began detecting gamma-ray bursts with a distinct signature different from that of a nuclear weapon. These signals arrive from every direction, not originating from Earth. Since then and up until now, we continue to receive indications of cosmic rays reaching Earth, with most of them likely too distant to pose any risk. Our atmosphere is highly effective against powerful radiation particles, but these are not your run-of-the-mill fireworks. Their power is so immense that if one were to occur within our own galaxy, it could obliterate entire solar systems, planets, and yes, all life on Earth. Evidence suggests that a gamma-ray burst may have triggered the Ordovician extinction event, one of the 5 major extinction events in Earth's history, which occurred around 450 million years ago, leading to a significant decline in marine species. These cosmic events aren't confined to a single corner of the sky. They're across the whole universe, popping up at random. On January 14, 2019, a colossal gamma-ray burst was detected. These bursts shone so brightly that their light seemed to originate nearby, perhaps within our own galaxy. However, astonishingly, this was not the case. Fortunately, the Hubble Space Telescope captured these massive gamma-ray bursts, known as GRB 190114c. These bursts were so intensely energetic and luminous that, despite appearing to be close by, they actually originated from a galaxy 4.5 billion light-years away. This means that the light from this event began its journey when the Earth was just forming, a staggering distance to consider. When scientists crunched the numbers, they concluded that the explosion released more energy than our Sun will produce in its entire lifetime, possibly making it one of the most energetic events since the Big Bang itself. With a brilliance that momentarily outshines the entire universe, the question arises, what kind of force could generate such a devastating surge of energy? One thing is certain, we are incredibly fortunate to be situated so far from such an energetic event. Now you might be wondering, why are these gamma-ray bursts so unpredictable? Well, that's a good question. These cosmic fireworks are the result of some of the most violent and energetic processes in the universe. Here is our best guess for their origin. First, let's understand the monstrous force we are dealing with. One of the most powerful explosions in our universe is the death of a star, a supernova. But when we consider the truly massive stars, they give birth to hypernovas, which are 100 times stronger than a supernova. However, even a hypernova, when you crunch the numbers, doesn't compare to the immense energy unleashed by those colossal gamma-ray bursts. So, what can create something even more powerful than a hypernova? Here's our best guess. Imagine a magnifier that focuses the photons of light into a denser, single point, increasing its energy. Now imagine a massive star, so hefty it makes our sun look like a speck of dust, reaches the end of its life. With a final dramatic gasp, it collapses in on itself, causing an explosion so powerful, 100 times energetic than a supernova. It can also give rise to a black hole. The black hole voraciously pulls in materials, creating a disk that orbits around the black hole at speeds approaching the velocity of light and tremendous heat. The magnetic fields generated so much energetic eventually reach a breaking point, causing the energy escaping due to the disk's rotation to burst out in vertical beams. This entire process can occur in less than a second, creating the devastating gamma-ray burst that consumes anything unlucky enough to stand in its way. But wait, there's more. Some scientists suggest another idea, and they propose that gamma-ray bursts could also be the result of the merger of a neutron star and a black hole, or two neutron stars colliding. Imagine two of these bad boys crashing into each other at high speeds. The origins of gamma-ray bursts are still a matter of hot debate among scientists. So if this phenomenon could be responsible for our most devastating past extinction event, and if we know it keeps happening all the time all over the universe, how close is too close? Is it possible for a gamma-ray burst to return and finish what it started on planet Earth, leading to our extinction as well? Imagine a cosmic cannon miles away, sending a beam of energy speeding through space at the speed of light. And we are the sitting ducks. If one of those beams hits the Earth, will we have a chance of survival? It's highly dependent on the distance of the explosion, which would make the difference. 100 light years away from us, well, it would be the end of us. Any living creature would get fried. And to give you an idea of what that means, there are approximately 14,000 stars within 100 light years of Earth. If any of them were large enough, their death would spell our demise as well. Fortunately, there is no known massive enough star within our radius of 100 light years capable of generating a gamma-ray burst. So, hold on a minute with that underground bunker. What about 8,000 light years away from us? Well, that would be a slow death for all life on Earth. As the first thing you'd notice, these rays travel at the speed of light, creating a fleeting flash before a massive electric pulse engulfs everything. Instantly, our technological devices would be wiped out, causing chaos as phones, cars, and even airplanes plummet from the skies. Subatomic particles would rain down on all living things, obliterating their DNA and leaving destruction in their wake. And even if you could find shelter from all of the chaos outside, our ozone layer would start to peel away like an onion under a chef's knife. Without the ozone layer, harmful ultraviolet radiation from the sun would turn the Earth into a giant frying pan. The resulting heat could potentially lead to mass extinctions, with humans on the list. Plants, animals, and even the tiny microbes, all gone. Sounds scary, right? But don't start packing for Mars just yet. The odds of a nearby gamma-ray burst are very slim. While the chances of a gamma-ray burst wiping us out are pretty unlikely, it might be worth keeping that tin foil hat handy, just in case. When we gaze at the cosmos, there's a more immediate threat that should perhaps concern you more. A seemingly innocuous icy rock hurtling through the solar system. To learn more about the risks it poses, watch the next video.